Hello, people. Welcome. These are exciting times. I'm on the road. As you can tell, I'm not in my usual office. I'm, I was in Ireland, then I was in Arizona, then I was in Boston, and honestly, I don't even know where I am right now. I'm somewhere. I'm not at home. Anyways, brought to you by the Kalis Institute. We're going to talk about some exciting new stuff. And so, I don't know if you guys have ever heard of this Lou Van Hook. You remember Lou Van Hook? Did you ever take biology? Probably you did. Remember Lou Van Hook? He was the guy who invented the very first lens, the very first microscope. And I love reading about the history of science. And so Lou Van Hook um, was a lens maker, and he figured out how to grind this piece of glass into this thing that would magnify, and was the first human being to ever see a bacteria, which is pretty cool. You can imagine how excited he was. And he was running around looking at his new using his new device to see all kinds of things. And he realized that there was this whole world of organisms that were alive, that were surrounding us, that we didn't know were there until he invented the microscope. And, true to form, he was ridiculed. People thought he was seriously mentally ill because he's saying, I can see things that no one else can see. And the funny part of the story is that no one else could make lenses as good as this guy could. So, and he didn't want to tell everybody how to make this lens because, he had a little thing going on, right? He wanted to probably sell them or whatever he was doing in this little microscope world. But anyway, so it was a long time until people accepted that this was actually happening. It was a really long time until other people were as good at making microscopic lenses as Lou Van Hook was. And pardon me, I'm probably not pronouncing the Dutch name very well. So anyways, that has been how we've been looking for organisms for a really long time. Okay, we get bigger and better and fancier microscopes, but basically, when you send in a stool test, primarily since Lou Van Hook, right, since his work was finally accepted by the different scientists of his era hundreds of years ago, we've been looking under microscopes, trying to find parasites, bacteria, all kinds of different organisms. And then, of course, people develop cultures, right? So you could actually put a stool sample in a petri dish and try to grow out something in a culture. And that's what we've been stuck with. When I was first in practice, I mean, I'm not that old, I'm not like 100 years old. It's like 30 years ago, there was, OMP, which is a human being looking under a microscope, and culture. And then along came antigen testing. That was pretty revolutionary. Along came blood antibody testing for parasites. That kind of came and went. I don't know if any of you are old enough to remember that. But for a while, there was a lab in Beverly Hills called Immunosciences that was doing these blood antibody tests for parasites. And the government didn't like that. They shut them down, which was kind of unfortunate because they had some pretty cool testing. But anyways, antigens, antibodies, and then the advent of the DNA testing, or PCR. And so there's been, a fairly large number of labs in the integrated functional medicine world that have been doing PCR or DNA-based testing. And so, not to get too technical about it, but polymerase chain reaction, what's happening is they develop these probes, and rather than looking under a microscope, they're trying to detect the DNA of an organism. And the limiting factor with PCR testing has always been that you have to know what you're looking for, right? So you can't, with a microscope, the wonderful thing is you just look and whatever you see, you can find and report. With PCR testing or DNA testing, you have to develop these probes ahead of time so you're specifically testing for exact organisms, right? And so you have to predetermine what you're looking for with a PCR test. With a microscope, it's the opposite. You're just looking for whatever you can find. And so I don't know, PCR has kind of been stumbling around for a while, and then I don't know, in the last 10, 15 years, it's become more and more and more popular, right? And most of you are familiar with it. Probably you see it on all the major companies' tests. And there's an expansion now, much like Lou Van Hook, and his ability to see microorganisms for the first time. Now we can find these things using DNA. And it's, I think, as revolutionary a change as inventing the microscope, because it's just completely opened up our ability to understand the microbiome and all this kind of stuff. And so the latest entrant in this testing, new testing, is Doctors Data, a lab you're probably all very familiar with. They've been around for a long time, longer than I've been around. very tried and true lab based out of Chicago. And Doctors Data has been doing stool testing for a very long time, but what they did recently was invest in some new technology so that they could run the latest state-of-the-art PCR or DNA testing. And this test was just released. I got some of the first test kits in the country, I think, in my office, and I haven't even gotten any of the results back yet. We're just brand new, but pretty excited about this. Kind of like how Lou Van Hook felt when he was looking under the microscope for the first time, going, wow, I can see all this stuff no one else can ever see. And so I want to talk about this tonight and tell you a little bit about how this test is developed and some of the things that it can do for you in your practice. And we should all know all this stuff anyways, right? You want to stay up to date on what the latest testing is, and especially when there's a revolutionary up-leveling like PCR or DNA-based tests, and when they're changing themselves, okay? So a little bit about me, if you're not familiar with who I am. I'm Dan Kalish. Um, who am I? What do I really do? I don't even know anymore. I guess I'm a lead faculty member. That's what the slide said for the Institute for Functional Medicine. One of the biggest honors of my career so far is to work with the IFM staff. I've been doing that for a couple of years now, doing practical hands-on uh, sessions at the different IFM modules. And I did a research study with Mayo Clinic a while ago using the old school GI testing of all things. And I'm very excited in the last 3 years I've been working with Richard Lord, who's one of the early scientists that developed much of the work that we're talking about all the time, new, in terms of organic acids, fatty acids. He did the original PCR DNA-based testing many 12, 15 years ago. I've been in practice for a long time. I teach this class. I would love for you to sign up. We're starting a new group this week. So if you're interested in the mentorship, you should contact us, okay? And I can talk to you more about that. The class is starting right now. And I'm gonna now turn to a series of different methods here to show you. I've stashed all this. Here we go. All right. And I want to just put it in a framework, right? So we're going to talk about GI stuff for the rest of the session, but just want you to know that this is, an isolated. We're focusing on this one area, but we're acknowledging that there are many other areas, and that we do this neuroendocrine work really into all these other kinds of tests. But tonight we just want to focus on the microbiome. But when we're designing programs, I put the GI programs in the center of the 3 different systems that I work with: neuroendocrine, GI, and detox. But not to say that we ignore the other systems. We just happen to be focusing on the microbiome tonight. Okay. So, and we have a GI master class that I put together. It's like $50. It's if you're interested in this stuff, it focuses a lot on the microbiome and the new testing, and I tried to make it highly relevant for all this contemporary new stuff that we're talking about. So that's something you could check out too. Okay. But I wanted to, when we're about to look at the lab reports, and before we get into looking at the actual reports, I just wanted to break down a really simple way of analyzing these, because the data on the new reports is significantly, I don't know what you would say, more confusing, or it's significantly it's a more robust, larger amount of information that you're going to be seeing. And so I think it's very helpful for all of us if we have a way to kind of classify it and understand it, and a lens through which to view it, right? A lens through which to view it. And so in simplest terms, when you're looking at these complex tests that we're about to look at, you just want to see, is the microbiome disturbed? Are there GI organ issues that are impacting the person's health, or are there any pathogens? Okay, those 3 things. And so the microbiome analysis, there's all kinds of graphics and charts that'll help you understand if that's happening or not. The GI organs are pretty straightforward. Most of you probably are already familiar with those markers. We can go over them if you want. And then the pathogens are pathogens, right? Those are the bad guys. And so we want to figure out, when you're doing a treatment, what of the different stages a patient is and what level of practice skills development you feel comfortable with, and then what level of symptomatology the patient has, and then throughout all that, put together a program. That's kind of the goal. So I'm going to cut over just for a second and show you a sample report. And here we go. Now we're off and running. So this again is the new Doctors Data GI 360 stool test. And you will see on the very first page, they're looking at the microbiome, and the keywords these days, the buzzwords, abundance and diversity. So you're looking for a balance in the different types of bacteria that are growing in the gut. And the interesting thing about the microbiome is we haven't evolved to the point yet where we really understand what's going on. It's just like it's the ground rules and the groundwork is just being laid out at this moment, so that you can't say there's this one bacteria in the microbiome that's off and that's causing this disease or this problem. If we just fix that one thing, then things will be better, right? So we have to start to look at this in terms of bigger picture items like abundance. Is there an abundance of the organisms? Is there enough of these organisms growing? And is there a diversity of them? Is there a wide diversity of them? And then every company has their different ways of trying to classify this. And what Doctor's Data has come up with is his dysbiosis index, okay? And that'll show you in a little meter thing there, right? All the way to the right into the red, pinkish is bad, and all the way to the green is good, to the left is good. And what they're attempting to show you is a summary of all the different commensal bacteria taken together, and is that diversity, is that balance showing, or is a person looking like they have a dysbiotic problem, okay? And here's where things get really confusing. You have to think about this for a while, and I'm gonna try to describe this. So we have commensal bacteria, which are supposed to be there. Everybody has a slightly different version of these, but there's certain ones that we, in general, most of us share, right? And these are good organisms that are supposed to be there. However, there can be too much of a good organism or not enough of a good organism. That can happen. And then there are dysbiotic bacteria, and these are bacteria that pretty much everyone agrees shouldn't be there except for maybe in a little amount. And if they start to overgrow at all, then you're going to consider to have dysbiosis. So there's sort of the good guys that we're dealing with, and if they're really out of balance, maybe you have dysbiosis. And then there's the sort of in-between guys who are generally considered to reflect dysbiosis if they're overgrowing at all. Okay, and so and then they're pathogens, right? So there's almost like 3 different groups, and to make it even more confusing, a single organism can move around, right? So like H. pylori could be a pathogen. In another human being, in another circumstance, H. pylori could be considered a commensal or even healthy, right? Good for you. So just because you can name the organism doesn't mean if it's on the pathogen scale side or not, right? And so what everyone's trying to do is define this for us, especially with the commensal bacteria, because that's the most confusing part. So let me just show you. So with this new test, the GI 360 Doctor's Data, they have 54 commensal bacteria. 54, okay? That's a lot. That's more than anyone else has right now. And here they are right in front of you. I mean, most of us don't know what these do, let alone how to pronounce them, like Bacteroides fragilis, I can say that one, but these are complicated, right? And really, you're gonna have to have a PhD in microbiology to wrap your mind around this portion of the test if you're gonna try to look at it organism by organism. It's not like the old days when you just look at a test and the person has crypto and you go, okay, they have crypto. And so within these 54 commensal bacteria, because it's so overwhelming and confusing, while we're all learning what each of these is and how it works, and while the worldwide scientific community has kind of put together, what all this means, okay? In the meantime, there's been a group of researchers in Europe that have come up with a summary of looking at these 54 commensal bacteria that are all considered significant markers, and then they're comparing the highs and the lows and the normals and coming up with this dysbiosis index. All right, so this is an extra special thing. The dysbiosis index on the screen right now is telling you a quick summary of those 54 commensals. Eventually, and I've been studying this pretty intensively for 3 years, and I can't even pretend to know more than maybe 10 or 15 of these bugs in any even moderate level of detail, right? It just takes a long time. Each one of these you have to study for a while. So before, if you're not at that point, as I'm not, where you understand what all 54 of these organisms do and how they interact and how they work, you can look at something like the dysbiosis index, and it gives you a general summary of those 54 commensals and whether they're in balance or not. And they've got a bunch of research out of Europe now, which is wonderful, that Doctor's Data has accumulated. And they were doing the talk at the IFM conference recently where I was attending. And the speaker there, a wonderful speaker, and was describing basically how these researchers in Europe are starting to make correlations between diseases, like real diseases, like Crohn's disease or ulcerative colitis or IBS or IBD, real GI problems, and these commensal bacteria. So that work is just starting to be sort of blossom now. And this dysbiosis index is an attempt by these researchers to try to help us clinicians understand, is this commensal bacterial situation problematic and causing inflammation and tissue damage and issues with the gut, or is this commensal bacterial situation, this microbiome, in pretty good shape? Okay, and so that's what that dysbiosis index there is for. And then the test also includes what you would expect, reporting on culture and the standard O&P and these kinds of things. And then all the regular GI markers, right, that we're all familiar with. So I don't want to dwell on that too much because you guys are probably familiar with that stuff. Things like pancreatic enzyme analysis, stuff like that, right? It's multiplex PCR. I've seen these machines. I've been in a bunch of these labs. They're pretty cool. I don't really know how to work them. If you put me in a room with one of these, I'd be kind of lost. But at least I've seen them. And it's complicated, and you walk through, and everyone has white coats on, and there's a lot of technology going on here. And it's a big investment for these companies to do this, right? And I think it's kind of, it's a reciprocal relationship, right? We need these lab companies, so we should be ordering these tests because we want to, in a sense, support the lab so we can get better and better technology and better results for our patients, right? And at the same time, the labs obviously want to support us and get us clinical results. So this is the latest entry in this, okay, these 54 commensal bacterial markers and that quick summary that shows you whether they're relatively imbalanced or not. All right. Sorry, I don't know what that's coming from here. Let's get rid of that. Okay. So, and let's go on. I just want to show you the, and there's different platforms and different ways that people do PCR, okay? Just so that you know, not all these companies are the same. And I'm just going to breeze through the rest of the test, and then we'll go back to some of the lecture materials. Oh, there's my favorite organism. See, Akkermansia mucinophilia. I've studied that one a lot. It's a cool one. It's the one that's out there in the mucin layer of your gut, and it feeds on the mucin, right? It's out there munching away on your mucin and keeping your intestinal lining healthy and happening. It's fascinating, but that's more like a biology class. Like, you don't need to know the detail in each one of these organisms to really figure all this stuff out. And then here are the pathogenic bacteria, right? These are the ones that we pretty much all agree are problematic. You can see they include that in the test. And then there's the regular parasites that we're all familiar with: blastocystis, crypto, Dientamoeba fragilis, Giardia, stuff like that, right? And then the test also includes the lesser, not as popular parasites, the ones that are maybe not, really focused on in medicine as much, things like Endolimax nana and stuff like that. And it has markers for the worms and the flukes, which is handy. Don't see those very often on the testing, but they show up once in a while. Roundworms. And then you get into the other markers, right? Yeast, muscle fibers, red blood cells, the crystals, these kinds of things. So this is more like what you're used to seeing on a standard stool test. That's also included in the GI 360. And then let's see. Is that it? Let me scroll down a little. Oh, no, that's not all. Here's the pathogenic bacteria. And so in conventional medicine, they have different rules than we do. In integrative and functional medicine, some of these organisms that we worry about that the conventional doctors don't, like, for example, yeast or fungal overgrowth in the gut. And then they have a susceptibility section here. And then I think this is really important too, right? The digestion and absorption section, elastase, fat stain, what's happening in the body in terms of carbohydrates, the inflammatory markers like lysozymes, calprotectin, the immune markers like secretory IgA, and very, very important, we'll talk about this in detail in a second, short chain fatty acid markers that are so critical, and then things like intestinal health and beta-glucuronidase. Right, so all that information, now I want to go back and show you what I'm trying to do here in terms of putting together systems for interpretation. And hopefully this will help you as well. So 3 different stages we're trying to identify from all that information I just flashed on the screen. 3 different things you need to decide, are any of these 3 things happening in this patient? And if they are, what am I going to do about it? So number 1 is, what's the state of the microbiome? You look at the short chain fatty acids, the butyrate marker in particular, right? You look, we're probably not going to have time today to do this, but you can look for polyphenol markers on organic acids. You're talking to the patient about their eating habits. Typically, if they're not chewing their food well and they're rushing through meals, they're going to have problems with the commensal bacteria balance. And then on the correction side, we're talking about prebiotics and fiber, probiotics, and butyrate. Okay, and butyrate is a newer product that just came out earlier this year. Pure Encapsulations carries it. It's pretty amazing. The brand name is called Sun Butyrate, and just kind of mind-numbing how effective that product is for people with really bad GI problems. It's a liquid, tastes pretty good. You do a teaspoon 3 times a day, and it's kind of like a cure-all for the gut. It's pretty incredible. New product that's just on the market. You should know about that too. Sun Butyrate from Pure Encapsulations. Okay, and so what we're really concerned about here is short chain fatty acid markers, polyphenol markers, right? And that diversity index that we just saw on the microbiome, okay? So that would be like your qualification for the person being what I call a stage 1. Stage 2 would be where there's organ dysfunction. Now there might be a problem with the stomach or the pancreas or the gallbladder or the small intestine or large intestine, right? Now there's organs that are involved. And then again, you can use supplements like betaine HCl or enzymes or gallbladder support, secretory IgA support, and leaky gut repair, these kinds of things. And then the last stage, if this progresses and gets even worse, would be that the person has picked up a series of pathogens and you want to either kill them or you want to go back and treat the stage 1 so that you can restore the microbiome. So if you have a patient that has GI pathogens, you may still want to go back and treat the earlier stage issues, the microbiome issues or the organ issues, because oftentimes that's why they have a pathogen in the first place. If you just kill the pathogen, they may just redevelop another pathogen, right? Or that Giardia that they have may have been lurking around in their gut for 20 years, and it just started to cause symptoms recently because the microbiome fell apart because they took some antibiotics for a surgery or something like that, right? So you want to be able to seamlessly move between stage 1, stage 2, and stage 3 treatments. And again, stage 1 is treating the microbiome itself, prebiotics, fiber, butyrate, things like that. Stage 2 is treating the organs. Don't underestimate the gallbladder. So many of our patients have gallbladder problems that are missed. Giving gallbladder support or enzyme support or leaky gut repair, right? Getting the organs working better. And then ultimately, if needed, either antibiotics or antimicrobials to get rid of potential pathogens, right? And so, let me see, I'll show you here. Yeah, so when you're working with a stage 1, to reiterate, you assess the status of the commensal organisms on the stool test. And I think this is the most confusing part. I haven't met anybody that understands how to do that, to be honest. Each of the lab companies that we work with has all these commensal organisms, and it's just confusing. No one really knows what to do with it. You want to, in general, look for patterns. Like with the GI 360, they're going to tell you they have that dysbiosis index. Remember, let me just show you again here. They're trying to take the guesswork out of it so you can just see right away if there's a problem or not. That's that little meter there, right? The dysbiosis index. If that thing's pegged all the way into the bad zone to the right, then they have a dysbiosis problem based on those commensal markers. If it's in the green, then you're going to suspect they don't have a problem. Okay. Sorry, I lost my way here. There we go. So assess the status of the commensal organisms on the stool test. If you're using other companies' stool tests, you just kind of got to eyeball it and look and see. They seem like there's a lot of them that are really high, a lot that are really low, and most of the companies will have a graphic image. You can look at it and see if it seems like the diversity or the balance is there or not. But you really need to come to grips with, we all do, how to look at those commensal markers and feel confident in explaining that to a patient. If you're sitting there and you got this lab report and there's a page or 2 or 3 pages of commensal GI markers and you don't know how to really talk to that, you're in trouble because it's not good to order a lab that you can't explain, right? So it's really important to have some talking points around the commensal organisms. We should probably do a talk around that someday. You know, and again, I've been really fortunate in the last 3 years to work with Richard Lord, and he spent a couple years just drilling me on these organisms. And here's this one, and Acromantia, and what it does. And here's M. smithi. This is the research behind it. This is why it's important. This is what it does. You know, here's Bifidobacter. Here's Lactobacillus. And you really gotta, you know, as time goes on, you know, grapple with these organisms and start to understand them. But because we're all ordering tests in real time right now, and it takes a couple, 3 years maybe or more to even understand a handful of these organisms, you want to have something like the dysbiosis index, right? So you can get at least a quick summary and maybe study 2 or 3 of them so you can at least talk to patients about a few of these organisms intelligently. And not just, you know, what happened to me for all the previous years is I get the lab report back, and when I got to the commensal organism page, I just kind of turn it quickly if the patient didn't see it. And if they asked me about it, I would be like, well, if those are really high, it's dysbiosis. If those are really low, you need a probiotic. I would just kind of keep it at that, right? So anyways, that's important for you to get familiar with and comfortable with that. And you guys are interested, I can do a whole nother talk on the commensals, specific commensals, so you guys have some talking points there, okay? Happy to do that. And then you also want to be able to assess the status in terms of polyphenols on organic acids. And let me just show you that real quick here. What do I mean by that? Some of you may already know this, some of you may not. These are just some examples from class. So what we do in the mentorship class every week is you pay to sign up, and you take this amazing class, and you have lectures that you listen to, right, each week. And then we also have a live call each week where we review cases. And this is a case from, I think, just a week or two ago. And we're looking at the GI markers here, but I want to show you the organic acids for this example. Here we go. So on an organic acids test, and this is an organic acids test from Genova, you'll see on the last page here of markers, benzoate, hippurate, phenylacetate, phenylpropionate, parahydroxybenzoate, and parahydroxyphenylacetate. Do you see the phenols in there? Phenylacetate, phenylpropionate. These markers, numbers 36 through 41, are testing for polyphenols. Who knew? If these markers are high, it means the person has potentially maybe some dysbiosis going on. If these markers are low, however, it means there's not enough dietary polyphenols in their diet. Okay, there's not enough polyphenols in the diet. And that's your green teas and your blueberries and all the good stuff, right? So if the person has low markers on this part of the organic acids, you should give them some kind of polyphenol supplement, as well as encouraging them to eat polyphenols in their diet. I had a patient just yesterday, a really tough GI case, who solved the case. We solved the case basically when she started to take a bunch of polyphenol supplements. Her bacterial markers were low in this section, the polyphenols were taken, and then poof, her GI problems disappeared. I'm speaking very carefully here because I didn't prescribe the polyphenols, okay? She listened to one of my lectures, this is a true story. She listened to one of my lectures online on some YouTube thing or whatever, and then I didn't actually physically tell her to take polyphenol supplements. She heard the lecture, she saw her lab, and then she took them on her own, and then she made herself better. But I'll take some credit for it because at least it was my lecture that she listened to. Okay, so assess the status of commensal organisms, get familiar with 3 or 4 of the organisms so you have some talking points with patients, right? And then assessing the status of the polyphenols, we just looked at that, and then you want to be able to apply treatments. Okay, and I call it labs to lifestyle, right? Where, for example, if the short chain fatty acid bacteria are low, you want the person to eat more fibers. So you're getting this lifestyle change based on the lab. The polyphenol markers are low, more fruits and vegetables. You're getting the person to do what they know they should do, eat more fiber, eat more fruit and vegetables, but you're doing that based on the labs, right? Another way to look at this, I'm going to skip through some of these slides because we're going to be a little short on time here. Is that there's different categories of these commensal organisms. There's groups of them, and here's a list here that are what they call high abundance. There's a lot of them, right? And they convert fiber into short chain fatty acids, which is kind of an interesting thing. And they break down these fibers, and as a normal part of their life cycle, turn them into dietary fat. I mean, turn them into fat, essentially. They turn them into short chain fatty acids, which are then used as a fuel supply or as a food by your intestinal lining cells, right? Which is kind of crazy. And so you can also look at this as the bacteria that make the short chain fatty acids. There's other groups of these bacteria that make hydrogen. Okay, there's groups of these bacteria that consume hydrogen. Right? And so there's all different kinds of things going on. And we're not going to get into the details on this tonight, but I just want to bring up the subject that when your bacteria, your healthy bacteria in your gut, don't have the fiber, don't have the ability to break down the fiber into short chain fatty acids, there's not enough hydrogen in the system. These organisms in different categories of these organisms start to die, right? And that is what we're talking about as a problem with the microbiome. And so at some level, this is an ecosystem where you have hierarchies of organisms helping one another in different ways, right? So you have the ones that break down fiber into short chain fatty acids. You have ones that are making hydrogens. You have ones that are feeding on the hydrogens that the others are making, right? And each one of these groups of organisms is helping the other. And what we often see in our patients is that there's, a collapse of the microbiome, and that, as a consequence of that, people start to have a lot of GI issues. Okay, those are some of the older tests actually there. All right, let's see here. I'm gonna go back. Let me just review a couple of these other things here. I've got another report. I think here. And I think I might have, oh yeah, here. Let's take a look at this. All right. So I tried to put together a summary page here for people, for all of us, about how I kind of think of this schematically. So if you look at the top here where it says practitioner, we're thinking about when you're designing a program, you're thinking, am I going to treat the microbiome, treat the organs, treat the pathogens? Remember, if they have a pathogen, you may still want to treat the microbiome as the initial stage of correction. You don't have to just go after the pathogen right away. So a lot of this, I think, is also going to, revolve around where you're at and what your experience level is like. And the very interesting thing to me is that as I see the more and more experienced doctors, 30, 40 years in practice, they often revert back to doing the simplest treatments first. So some of your most sophisticated doctors who have a Giardia or Cryptosporidium case will treat the microbiome first and not try to kill the organism. It's interesting. I've always been a kill the organisms first and ask questions later kind of person, but you have to really start to think through that. After 25 years for myself, I'm starting to think like the old guys, right? And thinking, am I going to go after this Giardia, or maybe I should fix the microbiome? Maybe that's a better option. Is the microbiome messed up? Well, you look at your dysbiosis index, you look at your commensal bacteria markers, and that's why you need to become familiar with that portion of all these tests. And it's arguably, the microbiome portion of these tests are arguably the most important portion of the entire lab, right? Because the pathogens are just pathogens, and you can kill them or not kill them, you have to decide that. But where the dynamic went wrong, where the person first started getting sick, is when the microbiome collapsed. So you want to go back to that origin of the problem and make sure that in addition to getting rid of the Giardia or crypto, you end up at the end of the patient treatment with them having a healthy microbiome. That is kind of the name of the game now, okay? So first step is you figuring out where you're at. Second step is figuring out the patient. Are they a stage 1, 2, or 3? Is it a microbiome problem, an organ problem? Is it pathogens? And remember, if they're a stage 3 and they have like a yeast overgrowth and H. pylori and Cryptosporidium, you don't have to necessarily kill everything first. You might want to treat the gallbladder first. You might want to treat the microbiome first and see what the responses are like before you escalate to the killing. You should be able to seamlessly move between these 3 stages of treatment in any case, right? And if the person, for example, doesn't have any pathogens, then you're still going to often find there's a microbiome disturbance. And of course, you can treat at the microbiome in that way as well. Okay. And then in terms of the actual protocols, this third step here is based on your stage of development, the patient's stage. You want to create a protocol that is heavily influenced by lifestyle changes as well as focusing on supplements. And I really like to use supplements in my practice, and I use them with every single patient. I'm not against using supplements by any means, but also, try to make sure that we, balance that out with the lifestyle changes as appropriate. Okay, so just a quick refresher here. Let's look at this again. You've got the Doctor's Data 360 lab. You've got the little spider web thing, right? It's just trying to show you the abundance and diversity. You've got the the dysbiosis index, which clearly shows that summary of the commensal bacteria, right? Expected flora on the left-hand side. Key findings on the right. This patient had some dysbiotic bacteria, Campylobacter, Citrobacter, some yeast. Elastase low, meaning they need more pancreatic enzymes. Butyrate low, meaning they need butyrate. pH high, meaning the pH is off, and they probably need to change their diet. So the confusing thing to me, and probably to you a little bit, is that these organisms are not so clearly defined in that the commensal organisms that are considered normal, if they're overgrowing or undergrowing enough, can reflect that there's a dysbiotic condition. Let me say that again. The commensal organisms, which are normal and should be there, if they're thrown off far enough, will reflect a dysbiotic condition. And that's what that dysbiosis index is trying to show you. Independent of that, to a certain extent, you can have a dysbiotic, quote unquote, organism like Campylobacter or Citrobacter or Klebsiella or Morganella or all those guys, okay? Those are not considered typically true pathogens. They don't kill people. They're not that harmful, but they generally put people at risk for inflammation and autoimmune diseases and things like that, right? So you have commensal bacteria that can go bad and create dysbiosis. And then you have this other sort of subcategory of dysbiotic bacteria, the Campylobacters, Morganellas, Klebsiellas, that pretty much everyone agrees are bad. That's why it's a little confusing, more than a little confusing, right? So dysbiosis can arise because these 54 commensal bacteria markers are off. Dysbiosis can arise because they have dysbiotic bacteria. So let me just show you one more time with the actual lab report. So here are the 54 commensals. And again, there's a summary up there that we just looked at that just attempts to, through the researchers in Europe, kind of summarize this and tell you if it's bad or not. And you should learn, about, I would say, at least 3 or 4 of these organisms so you can have some talking points with patients. I can probably speak intelligently about 6 of these and peripherally about maybe 10. But I don't think you need to be familiar with more than 3 or 4. You certainly don't need to know each one of these. So that's the commensals, right? So if those commensals are off, you're going to see it in the dysbiosis index. And that's sort of commensal bacterial driven form of dysbiosis. Then we have the viruses, and then we have these bacteria that are pathogens, right? Those are the ones that everyone agrees are bad. Of the parasites, and you guys are probably familiar with those. I'm not going to dwell on that. The protozoa, the tapeworm, flukeworm, blossoworm, roundworm. But I want to get to this other section here because this is where it gets confusing. Those are pathogens, imbalanced bacteria, dysbiotic bacteria, okay? Campylobacter, Citrobacter, you see those? There should be some more here. Oh no, here they are. So you can have dysbiotic bacteria, Campylobacter, Citrobacter, the other ones that are often reported, Klebsiella, Morganella. Those indicate dysbiosis because of the actual organism that's present, if it's there too much. However, independent of that, we also call it dysbiosis when the commensal bacteria are out of balance. And that's my sort of focus, I think, that we should all engage in as a community, is understanding these commensal bacterial markers better so we can report on them to our patients. We can engage with these new kinds of tests like Doctor's Data has released. I mean, these guys invested a lot of time and money and put their company at risk for us to get a better quality test. And it's just incumbent upon us to use them, support them. And if we don't, they're going to go away. I mean, they're a business like any other business. And if people order this test, then, it's good for all of us and our patients. It's good for this company as well. In a sense, we're supporting their investment in this new technology and their, willingness to import all these things from Europe, buy the equipment, set all this stuff up so we can get these 54 commensal markers. I think it's really, again, an exciting time, back to like Lou Van Hook with the microscope, where we have this opportunity to really look at the microbiome for the first time in this level of detail. And I find it incredibly exciting. And I want to just encourage you before we wrap up, I can handle some questions too if you guys have questions. Um, that even though these tests are overwhelming and none of us really understand them, don't 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 be intimidated. Just order 5 or 6 of these. I got 4 of them out already. Just do it, and get on the phone with Doctor's Data or come to one of my free webinars. And we're doing a special thing here. If you take my GI masterclass, it's like $50. Then you can join a group and we're going to do free lab reviews where I'll go over the tests with you guys and explain what they mean. Okay, so we really want to encourage you to not be intimidated. You can check out our GI masterclass, and then you can join one of these things where you send in your lab, and just like I do in the regular training program, we'll go over it in a session like today and really get into the detail of what it all means. Okay. All right. So let me go through. There's a few questions that came in. Someone said yes, do a talk on commensal bacteria. I'll probably put that together because that's something I've been wanting to do for a while. The slides and audio available. Yeah, this is recorded, and we'll send out a link to the copy of the recording probably tomorrow. Okay. Let's see. Yeah, so there are a variety of other testing companies that do PCR testing, and I use them all, and I would encourage you guys to explore this as much as possible. This is just the newest entrant into this whole thing. And in fact, I use all, 3 different lab companies on a regular basis for the stool testing. I just want everyone to know about this. And you should order 6 or 10 of these and then compare them to the other tests that you're doing, get a sense of where they're going to fit in your overall recommendation, okay? And to patients, because I use more than one company in my own practice. I don't think there's any single test that's necessarily the best of all, okay? And then David is mentioning diagnostic solutions. Yeah, so there's diagnostic solutions, there's Genova, there's Doctor's Data, there's Diagnostics, and there's Biohealth Diagnostics. Those are the 5 that I have used on a pretty regular basis throughout the years. Genova, Doctor's Data, Diagnostic Solutions, Diagnostics, and Biohealth Diagnostics. Okay. All right, I'm going to wrap it up for now. I hope you guys are doing well out there in the rest of your lives. And a couple of quick questions here I missed. All right, hang on a sec. Cost of the test, they're all about the same. They're all like $300 to $400 range, right? So all the companies are competing on price point. All of a sudden, everyone's asking a million questions. Wait a minute. Okay, let me see. Is this covered by insurance? I don't know. I don't take insurance. I'm all cash. What type of patient in particular do you use this lab test for? In my practice, we do stool testing on every patient. The foundational concept to me of functional medicine is that everything comes from the gut and that the microbiome is the master of all. And so you basically have to run a stool test on every patient. If you're really doing functional medicine, you can't just skip it. And then if you how to order a test, just contact Doctor's Data and they can get you guys set up, okay? All right, everyone. You guys take care of yourselves. We'll catch up with you next time. And again, if you want to order a test, get the GI Masterclass from my office. And let me see. I don't have a promotional thing on it, but get the GI Masterclass, and then you can join our free webinar where we can review labs, and we'll have that open to the public sometime early in the new year, probably. Okay. If you guys are interested in the mentorship, reach out to us. Otherwise, we'll catch you next time. Bye for now.